Assalamualaikum warahmatullahi wabarakatuh and hello everyone. So in this video, we will learn about statistical analysis about the data and sampling. Alright, so these are the learning outcomes of this lesson. So at the end of this lesson, you should be able to understand the needs and steps in conducting statistical analysis, and then you should be able to differentiate different types of data and explain different types of sampling methods. So what is statistical analysis? So basically, we use statistical analysis to investigate trends, patterns, and relationships using quantitative data. And we use it to draw valid conclusions. Statistical analysis requires careful planning from the very start. We need to specify hypotheses and make decisions about study design, sample size, and sampling procedure. And after we have collected the data, we can organize the data and summarize them by using descriptive statistics, and then we can use inferential statistics to formally test the hypothesis and make estimates about population. And then we can interpret and generalize our findings. So this is the statistical analysis. So there are several steps in conducting statistical analysis. First one, we need to write hypothesis and plan for our study. After that, we can conduct the data collection, and we can summarize the data with descriptive statistics, and we test the hypothesis with inferential statistics, and then we will interpret the results. So first of all, let us take a look at the hypothesis and plan. The goal of research is often to investigate a relationship between variables within a population. It normally starts with a prediction, and then we use statistical analysis to test that prediction. Statistical hypothesis is a formal way of writing prediction about a population. Every research prediction is rephrased into null and alternative hypotheses that can be tested by using sample data. Null hypothesis always predicts no effects or no relationships between variables. Alternative hypothesis states research predictions of an effect or relationship. Okay, what about plan? So basically, plan involves overall strategy for data collection and analysis, and also statistical tests to be used to test hypotheses later on. We should decide between descriptive, correlational, or experimental design. Experiments directly influence variables, whereas descriptive and correlational studies only measure variables. So basically, experimental design is used to assess a cause and effect relationship by using statistical tests of comparison or regression. Correlational design used to explore relationships between variables without any assumptions of causality using correlation coefficients and significance tests. And then descriptive design is used to study characteristics of population or phenomena by using statistical tests to draw inferences from sample data. Alright, so basically we need to operationalize variables and decide exactly how to measure them. We need to first take a look at the level of measurement. We need to decide what is the level of measurement of our data. Basically, it represents the type of data they contains. Basically, it can be categorical data, which represents groupings. It can be nominal or ordinal level of measurement. And then it can be quantitative data, which represents amounts. It can be interval scale or ratio scale. So there are many variables that can be measured at different levels of precision. If a variable is coded numerically, it does not automatically mean that it is a quantitative instead of categorical. So identifying measurement level is very important for choosing appropriate statistics and hypothesis tests, because some of the statistical and hypothesis tests can only be conducted on certain level of measurement only, certain data only. Alright, so this one is the level of measurement. So it is actually how precisely variables are recorded. So there are 4 levels of measurement, which is the first one is nominal, where data can only be categorized. Second one is ordinal, data can be categorized and ranked. Then we have the interval data, where the data can be categorized, ranked, and evenly spaced. And we have ratio, where data can be categorized, ranked, evenly spaced, and has a natural zero. So why level of measurement is important? So it actually determines how to analyze the data. Different levels limit which descriptive statistics to be used to get an overall summary of data and which type of inferential statistics to be performed on the data to support or refute the hypothesis. It need to be chosen before data collection begin, as variables can be measured at different levels. Alright? Okay, now let's move to the second step, which is the data collection. Alright, so basically sampling for statistics is quite important because in most cases it is too difficult or expensive to collect data for every member of a population. Thus we use sampling. So imagine like in Malaysia we have like we have like millions of population. So if we want to obtain the data for each of the citizens of Malaysia, it is quite difficult. It's very difficult and it is quite expensive to do so. Thus we will select a sample. Normally people only select a sample from the population. So statistical analysis allows applying findings beyond on samples as long as appropriate sampling procedures is used. Aim for a sample that is representative of the population. Okay, so why we need to do sampling? So first of all, because of the necessity. It is not possible to study whole population due to its size and its inaccessibility. Practicality, it is easier and more efficient to collect data from sample. Okay, the third one is the cost effectiveness. Basically, due to the fewer participants, lab equipments, and researcher costs. And then it is the manageability. Basically, storing and running statistical analysis on smaller data sets is easier and more reliable. Right, next is the data types. So basically, there are two types of data, which is quantitative and qualitative. Alright, so let's take a look at the quantitative first. So the results of counting or measuring attributes of a population is a quantitative data. It could be discrete, where it is a results of counting, and it only contain certain numerical values. It can be also continuous, which is the results of measuring, and we can measure it accurately. The second one is qualitative data, which it is a result of categorizing or describing attributes of a population. It generally described by words or letters. It lends itself more easily to mathematical analysis. Alright, sampling technique. So there are two sampling techniques that we can use. The first one is the probability sampling, where every member of a population has a chance of being selected for the study through random selection. The second one is non-probability sampling, where some members of population are more likely than others to be selected for the study because of criteria such as convenience or voluntary self-selection. So you can choose either for your sampling techniques. Alright, so let's take a look at the differences between the probability and non-probability sampling. Basically, we use probability sampling for highly generalizable findings. Random selection reduces sampling bias, and it can ensure that data from sample is actually typical of the population. Parametric tests can be used to make strong statistical inferences when data are collected by using probability sampling. Alright, so you may use non-probability sampling if you cannot get ideal sample. So it is much easier to recruit and collect data from, although it most likely can be biased. And non-parametric tests are more appropriate for non-probability samples, but they result in a weaker inferences about the population. Alright, so if we apply parametric tests for non-probability samples, make sure that the sample is representative of a population generalized based on findings. And sample must lack of the systematic bias so that we can use the parametric test. It can only generalize conclusions to others who share the characteristics of sample when there is external validity. If we apply parametric tests to data from non-probability samples, be sure to elaborate on the limitations of how far results can be generalized. So this is an illustration on the methods for the probability sampling. So alright. So basically, the random sampling, what it do, each sample of the same size has an equal chance of being selected. And then we have the stratified sampling, where the population is divided into groups called strata, and then we take the proportionate number from each stratum. And for the cluster sampling, we divide population into clusters or groups, and then we randomly select some of the clusters. And the last one is the systematic sampling, where it randomly select a starting point and take every n piece of data from a listing of population. Alright, next is the non-probability sampling methods, where individuals are selected based on non-random criteria and not every individual has a chance of being included. It is easier and cheaper to access but has a higher risk of sampling bias. Inferences to be made could be weaker than probability samples, and the conclusions may be more limited. However, it should still aim to make it as representative of population as possible. It is often used in exploratory and qualitative research. It aims is to develop an initial understanding of a small or under-researched population. So this is the illustration of how the non-probability sampling methods works. So we have the convenience sample, purposive sample, voluntary response sample, and snowball sample. So let's take a look at each. So basically, the convenience sample, it includes individuals who happens to be most accessible. It is easy and inexpensive way to gather initial data. We can't actually tell if the sample is representative of population, and it can produce generalizable results. Then we have the voluntary response sampling, where it includes individuals who happen to be most accessible. Basically, people may volunteer for themselves to participate in the study. At least it could be somewhat biased, as some people will inherently be more likely to volunteer than others, because it is normal, because some people want to volunteer and some people don't want to do so, right? So it may create bias. And we have the purposive sampling, where it is a judgment sampling, where we select a sample that is most useful. It is often used in qualitative research. Population is very small and specific. For example, like the experts. So we already select specific groups to answer our study, right? And then we have the snowball sampling, where basically the population is hard to assess. It can be used to recruit participants via other participants, and the number of people to snowballs as get in contact with more people. So we ask our participant to recruit another participant, and that's how we get our sample. Alright, the next one is the sample size. So the number of individuals you should include in your sample depends on various factors, including the size and variability of the population and your research design. It can be based on other studies or by using statistics. A sample that is too small may be unrepresentative of the sample, while a sample that is too large will be more costly than necessary. There are different formulas that can be used to calculate the sample size. Can be used depending on whether you have subgroups or how rigorous the study should be. As a rule of thumb, a minimum of 30 units or more per subgroup is necessary for our sample. Alright, so there are several things that we need to understand before we decide the sample size needed for our study. The first one is the significance level, which is alpha. We need to consider the risk of rejecting the true null hypothesis. Usually we set it at 5%. The second one is the statistical power, where we should consider the probability of study detecting effect of certain size if there is one. Usually we set it 80% or higher. And we should also consider the expected effect size. It is the standardized indication of how large expected results of a study will be. It is usually based on other similar studies. And then population standard deviation. So it is actually an estimate of population parameter based on previous study or a pilot study. Okay, next one is the sampling error. So basically, sampling error is the difference between a population parameter and a sample statistics. It happens even when we use a randomly selected sample. Random samples are not identical to population in terms of numerical measures like mean and standard deviations. it should be low to be able to generalize findings from sample to population. So we want the sampling error to be low. We can reduce the sampling error by actually increase our sample size. Okay, so I think that's it for this particular lesson. We have taken a look at how to write the hypothesis and plan for the study. We have taken a look at the level of measurement, the sampling errors, and what's not the techniques to do the sampling. We had taken a look at it, and we have go through how to do the data collection for the statistical analysis. Alright, so I hope you understand about it. So next week we will take a look at the how we can summarize the data by using descriptive statistics, and then after that we will take a look at how we can test the hypothesis with inference statistics, and then we will learn on how to interpret the results. So I hope you understand. Thank you so much for listening. Till our next lesson. Bye bye. Assalamualaikum.